Hi everyone, I'm Ryan from SmartCow's AIoT team, and I'm one of the people responsible for creating features and applications for our products. In this video, we'll go over the basic setup of the Apollo Audiovisual Dev Kit, where we will configure the onboard microphones, camera, and an external speaker in order to get them up and running. To make the setup process easier, Apollo comes pre-flashed with a customized version of the Linux Fortegra BSP, which includes the required drivers and libraries. This in turn avoids having to install these yourself, which helps you to quickly get the onboard peripherals and sensors up and running. Before powering on the dev kit, I'll attach an external speaker to it so that I can play audio through it. I have this half-watt speaker, which I will attach to the speaker connector located at the top left section of the Apollo dev kit. I'll also connect a micro USB cable between my PC and the Apollo dev kit, as well as an Ethernet cable to provide the device with internet access. Apollo runs off of a 12-volt power supply, which is included in the box. Once I plug in the supply, a green power LED lights up and Apollo starts to boot up automatically. Once the boot process is complete, a welcome graphic is displayed on the OLED display. This gives us a heads up that the Apollo dev kit is ready to be used, and we can start working with our sensors. We'll begin by opening up a terminal on the Apollo dev kit, which can be done in a number of ways. We can connect a micro USB cable to the kit and SSH into it using the IP address 192.168.55.1. Alternatively, we can use the network IP address for the SSH connection, or we can also connect a monitor, mouse and keyboard to the Apollo dev kit. For this tutorial, I'll use the first method. I'll start by opening up a terminal on my PC, make that full screen, and we're going to start by SSHing into the Apollo dev kit. So to do that, we'll type SSH NVIDIA, which is the username of our Apollo dev kit, and the IP address, which is 192.168.55.1. I'll also be adding the -X option, which will allow applications running on Apollo to forward their display back to my PC. And we can hit enter, where we'll be prompted to enter the password. By default, the password is NVIDIA, all lowercase. And we can enter, and we're logged into the Apollo dev kit. An optional but recommended step if you've connected your dev kit to the internet is to run sudo apt update and sudo apt upgrade, which checks if our installed packages are still up to date and upgrades them to their latest version if not. Once the update process is done, we can begin by setting up the mixers, which provide a way to interface the Jetson Xavier NX Studio peripherals. So, we'll be using the amixer command to do this, to which we specify the name of the sound card which we're using the -C flag, and the name of the sound card is Jetson Xavier NXA. And we'll use the cset command to set the multiplexer options. So we're going to type in cset name equals ADMAIF1 mux, and we're going to set that to I2S3. And once we hit enter, it's going to become configured. Just to double check, we've set the value to 19, and we can confirm from here that item number 19 is in fact I2S3. We can do the same thing for the speakers, but in this case, we're going to be setting the I2S5 mux. So we'll type in I2S5 mux. And we're going to be setting that to ADMAIF2. We hit enter, and again we can double check that it was set to a value of 2, and item number 2 is our ADMAIF2. And again we can clear to remove the clutter. After setting up the mixers, we can now test our peripherals by recording a 5-second snippet using the microphones, and we can play it back to the speaker. So, to record the snippet, we'll be using the arecord command. We'll select the sound card and the microphone channels by using the -D option, and we'll type in the name of the sound card, which is going to be Jetson Xavier NX, and we'll do a (0) to select channel 0, which is where we set our microphones to. We're going to set the number of channels to 2 for stereo recording. We're going to set the duration of the snippet to 5 seconds, so we're going to do -D5. We're going to set the sample rate to 48 kilohertz, so 48000. The sample format to 32-bit little endian, which uses the code S32_LE, and we're going to set the output file name to test.wav. And once we hit enter, we're going to start recording the WAV file and saving it to test.wav. Once we finish recording, we can query the size of the file using ls-lah and the name of the file that we recorded, and we see that it's a 1.9 megabyte file. We can then play back the recording using the play command, in which we specify the sound card and the output channel. So we're going to type in Jetson Xavier NX (1). We'll set the number of channels to 2, the same as recording. The sample rate to 48 kilohertz. The sample format to 32-bit little endian. And the name of the file name to test.wav. And once we hit enter, we're going to start recording the WAV file and saving it to test.wav. Lastly, we can also check out the onboard camera on the Apollo dev kit. So, first thing we'll do is to check out the list of support resolutions that the camera can run at. And to do that, we'll use the v4l2-ctl command. We'll specify the camera by using the -d command, so -d/dev/video 0, and we'll list the resolutions using the flag --list-format-ext. Once we hit enter, we'll see that the camera can support quite a large number of resolutions. Using GStreamer, we can then create a pipeline to configure the camera and open a window displaying the live feed. So to do that, we'll type in gst-launch-1.0. We will then use the CSI camera as the source, so we'll type in NV-Argus camera src. We'll then add a caps filter in order to set the resolution and the frame rate. So here we'll type in video /x-raw, open brackets, memory : NVMM. We'll use a width of 820, a height of 616, a frame rate of 30 frames per second, and an output format of NV12. We'll then add nv-vidconf to the pipeline, so we'll type in nv-vid-conv. And lastly, we'll type in xv-image-sync in order to be able to display our live feed. We'll then also specify the -e option in order to be able to safely terminate the GStreamer pipeline using the Control-C command. So once we hit enter, we'll hear the camera being configured, and we can see the output display. And in order to terminate, we can just close the window. And with that, we've come to the end of the setup tutorial. So, just to recap what we've accomplished in this tutorial. We connected an external speaker to the Apollo dev kit, powered it on, and then opened the terminal via an SSH connection. We then configured the mixers and used the microphones to record a 5-second clip of our voice, which we then played back using the speaker. We then listed the available resolution options for our onboard camera, and then we created a GStreamer pipeline in order to stream a live feed of the camera back to our PC over the SSH connection. If you have any questions or comments about this video, please leave them down below. We really appreciate the feedback. Thanks again for listening, and see you again in the next tutorial.